Okay, so here we are. We are actually going to look at some examples here. So make sure you got that notebook out and you are practicing these. So just make sure that when I have you pause this, that you guys pause and take time to go through this. If you are not doing that, then you are just writing stuff down. So you're not going to learn anything by just writing stuff down. So just watching videos doesn't doesn't teach me how to do things. I can actually practice it. So please make sure you're doing that. We're gonna have a lot of practice, but make sure you're kind of going through. So take a look at this graphic right here. Just trying to graphically show you the same idea I've been talking about over and over. But the idea is that things on the left are the same as the things on the right. They just have moved around, new combinations. So you guys can see the black atoms there in that propane are now the three black atoms in the carbon dioxide. So same concept, just more visuals. All right, so let's go over here. Here's the steps. Okay, so first step is you have to have an equation. Skeletal equation just means you haven't balanced it yet. So we have to have an equation that is 100% necessary. If you are given a sentence, we can't balance a sentence. We can't balance a set of words. And so it is your absolute first thing you do is to write it out. Now, you're not going to always have to write them out. We're actually starting with things I think that are a little harder for students. The practice I'm going to give you after we go through these notes, you're going to start by me giving you the formulas. But we have to know that if you're given a sentence, if you're given a a hydrochloric acid, you got to be able to turn that into an HCl. All right, count all the atoms of the elements in the reactants and products. And so we'll be doing this a lot. You count the left, you count the right. At the end, they do need to be the same. So it's really just an exercise in counting. Coefficients, that's a fancy word for numbers in front. Okay, so that's some chemistry vocabulary. So we're going to put coefficients in front to make sure that the atoms add up. So an atom is the individual chemical. So H2O has two H atoms and one O atom. All right, so we're looking at those atoms of each element. So we write coefficients, and then we look at them left and right, and then we reduce them. So let's say we put a 2, a 2, and a 2 in. Well, that's actually the same as a 1, a 1, and a 1. So, and then there should be an equal number of each type of atom on each side of the equation. So now we're going to have examples. So if you look here, we're going to have some examples. I'm going to work through these, so they are not going to be. We're not going to have them. We're not going to have them through the PowerPoint here. So let me go ahead and exit there because I think it's better to do them over here. All right, so we got that periodic table out, right? So we use that the entire time. That's our tool. And we got our notebook out, and we're gonna try these. So I'll do this first couple, and then let you guys loose on a couple. So I'll probably do 3 and have you guys do 2 or something like that. So here we go. So there's our sentence. So it says, write the balanced chemical equation for the reaction between hydrogen gas and chlorine gas that produces hydrogen chloride or hydrochloric acid or HCl. So we kind of gave you that one. So let's look at this. We've got some hydrogen. We got some chlorine, arrow. We're going to make some HCl. So let's go ahead and write that out. So hydrogen, okay, good, plus chlorine, good, arrow, HCl. All right, so now we're going to check the old Brinkelhoff. So we write it over here. Brinchlhof. Check the Brinkelhoff. Hydrogen is in Brinkelhoff. They're at the end, so it gets a 2. Chlorine's also in Brinkelhoff, so it gets a 2. I don't care about Brinkelhoff on the right. I care about charges. So +1, -1, crisscross, and they go away. So we always have to check the charges just like we did in the last unit, we got to crisscross and create the right formula. So we always check those charges. So here we go. It's a pretty easy one, but I'm going to start by counting my atoms on both sides. So we've got 2 H's here and 2 chlorines. Okay, so the left side, so if you kind of think of it as, okay, I got my don't want to use that pen. That's the highlighter. Let's go to the pen. So if you think of it this way, we've got reactants. Those are the things on the left. And then we got the products. Those are the things on the right. Okay. So currently we've got 2 H's on the left and we have 2 Cl's. Okay. So let's look at the other side. We've got 1 H and 1 Cl. All right. So remember that you got those little imaginary, well, not imaginary, we just don't write them down, little ones next to the H and the Cl. So it'd be 1. Dang it. There we go. So it'd be 1 H and 1 Cl. Okay, so let's look at this. And now let's think about the reactants and products. They're not matching. So we only get to put numbers in one position, and that's in front. So you get to put numbers here or here or here. Now you don't have to put a number there, but that is the only place that you get to put a number. I do not get to put numbers here or here. I don't get to change that. I don't get to change that. That is not an option. You only get to put numbers in this position here, and that is where the coefficients go. You don't have to, but you can. All right. So if you don't have a number there, it's assumed that that is a 1. Okay. So no number in front is assumed to be 1. So this is very easy. On this particular one, I'm going to put a 2 here, and then that's going to take care of it. Because what happens is if I put that 2 in front, it's going to multiply by these. So that becomes now 2 H's and 2 Cl's. Because basically think about it like math. If you look at it like this and think of those are little ones right there, that'd be 2 times 1 is 2, and 2 times 1 is 2. Okay, so that's how you want to think about it. The idea that it's basically distributing kind of like in math. And then you double check at the end. 2, 2, 2, and 2. Okay, everybody's 2. That's good. All right. Now, I didn't do anything with the, I didn't do anything special. Just toss the number in front. All right. Let's have you guys try this one. Try this next one. You try that on your own. See if you can get it right. So pause the video, and we'll pick up there next. All right. Hopefully you got it done. Hopefully you got it right. Here we go. Iron. We have done a lot of things with irons. That's Fe. And it's going to react with chlorine. And I probably should have put states of matter above like this. I got kind of lazy, so I probably should have put gas and gas like that. But what you'll notice is states of matter don't actually change the numbers. And so I just got a little lazy there. So I'll try and do a better job on this one. So here we go. We got solid iron, because they did go out of their way to tell us what these were, and chlorine gas. And that's going to form iron 3 chloride. So FeCl. Okay, so let's get some space here. Let's get rid of that. All right, so first thing, we're going to do charges and diatomics. So that's always going to be the pattern every single time. So let's do the diatomics first. Is iron in Brinkelhoff? It is not. Brinkelhoff does not have an Fe, so iron does not get a 2. Is chlorine in Brinkelhoff? Yes, it is. Brinkelhoff. So there we go. So I'm going to go and add in my 2 right there. Okay. So now we got to look at charges and crisscrossing, because I don't care about Brinkelhoff over here. That's a big mistake students make, is they do this. That's wrong. I don't care about Brinkelhoff because this is a compound. So you care about Brinkelhoff when you have chemicals that are alone. This is alone and this is alone. And so you have to check that. Things in compounds, that's what we learned last unit. Iron Roman numeral 3 means this is a +3. And we'll look up chlorine, it's a -1. We're going to crisscross them, and we're going to get that. Okay. Once again, chemistry builds on itself, so we want to keep using the tools that we learned in the previous unit. So let's take a look. What do we got on the left? What do we got on the right? So over here, let's change the pen color real quick. I've got 1 iron, and we've got 2 chlorines, okay? So let's look at the other side. The other side has 1 iron, so that's good. Oh, but it has 3 chlorines. That is not so good. Okay, so what you're going to have to do here is add some numbers. So if you have a 2 and a 3, common number between 2 and 3 is going to be 6, and so that's super common. So if you see a 2 and a 3, you're going to multiply this one by 2 and this one by 3. So that 3 multiplies, so 3 times 2. So if you think about it this way, 3 times 2, that's now going to equal 6. So now I've got 6 chlorines over here. So let's put the 6 right there. Okay, this side, 2 times 3 is also 6. So that's going to work out quite nicely. And so we've got 6 chlorines on both sides. Problem is the iron is now messed up. Now there are 2 irons over here. And on this side, we only have 1. Well, that's a quick fix. You just come up here and you drop in a 2. So there we go. We now have 2 irons and 6 chlorines on both sides. So if you look, we have everything we need with these coefficients. So it's a 2, 3, 2. That's what you were looking for. Hopefully you got that. Hopefully you got that right. If you missed it, kind of identify why. So, all right, here we go. Phosphorus and oxygen gas form diphosphorus pentoxide. Diphosphorus. We got some molecular stuff going on here. So, all right, pause it, give it a whirl, see if you get it right.